So in that last video, I just gave you what the value of the vertex is, but typically we want to be able to calculate it. So if we have our parabola or our quadratic function in the standard form, so that ax squared plus bx plus c, then we can find the vertex, which is this xy coordinate, using this right here. So the x coordinate is equal to negative b over 2a, so that's what we would calculate first. So we're going to find x equals negative b over 2a. And then all of this notation for y is just to say once we find our x coordinate, we can find y by plugging in to the original function and then just calculating the output. So what we have for this first example here is that function that we graphed in the last video, this x squared minus 6x plus 8. And if you are working through these lectures and it's fresh in your memory, then you'll remember that our vertex was 3, negative 1. But let's see how that comes through with using this formula. So if I want to find the vertex, then I'm going to use that x equals negative b over 2a. So for our function here, we have a equals positive 1, we have b equals negative 6, and we don't need c for this, but just for good practice, c is positive 8. So negative b, which is negative 6, all over 2a, which is 1. So again, be sure to use those parentheses because it's important for this one where the numerator turns positive. So negative negative 6 is positive 6 over 2 times 1, which is 2. So here's our x coordinate of 3. And then what we'll do is to find our y coordinate, we're going to look at f of 3. So we're going to plug in 3 into our function. So 3 squared minus 6 times 3 plus 8. We either put that in the calculator or we can just calculate it. 9 minus 18 plus 8. So let's see, negative 9 plus 8. And there's our negative 1. So what we get from this is our vertex is the coordinate, x is 3, y is negative 1. Alright, let's try it with a new function. So we have our function in standard form. We have an a of negative 2, b of negative 6, and c of 9. And we're going to find our x coordinate first. So negative b over 2a. So for b we're plugging in negative 6. For a we're plugging in negative 2. So negative negative 6 is positive 6. 2 times negative 2 is a negative 4. So this right here is a negative 3 halves. Or what we can do, since we'll be plotting these points, it's good to know the exact value. But if we're going to plot this vertex, it's easier to have the decimal form. So I'm going to change this to a negative 1.5. But either way works, they're both the same thing. Alright, so I'm going to find f of negative 1.5. So with that, we're going to plug into our function, negative 2 times negative 1.5 squared minus 6 times negative 1.5 plus 9. And this is a great spot to go over to our calculator. So let's go ahead and type that in exactly. So negative 2 times negative 1.5 squared, and then minus 6 times negative 1.5 plus 9. And we get a 13.5. And as you can see with this, if you wanted the decimal, or sorry, the fraction form of it, you can get that from the calculator. So 13.5 is our y coordinate. So for the vertex, we got an x coordinate of negative 1.5 and a y coordinate of 13.5. Alright, so let's bring this into this idea of kind of gathering the characteristics of the graph and putting it all together. So we have a of negative 1, b is positive 8, and c is negative 7. So a is negative 1, so because a is negative, this tells me that it's opening downward. So I know that when I graph this, I should have this general shape of a parabola opening downward. For the vertex, we'll have x equals, so negative b over 2 times a. So we'll have negative 8 over a negative 2, which is going to be positive 4. And then we just need to plug in positive 4 to get the y-coordinate. So we'll have negative 4 squared plus 8 times 4 minus 7. So negative 16 plus 32 minus 7. So that'll be a positive 16 minus 7, which is 9. So our vertex is the point 4, 9. Y-intercept, we're plugging in 0 into the function. So we'll have negative 0 squared plus 8 times 0 minus 7, which will just leave us with a negative 7. So we'll have 0, negative 7 for our y-intercept. For the x-intercepts, we're going to plug in f of x equals 0. So for negative x squared plus 8x minus 7. We can factor here. I know it can be a little bit of extra work. Let's use the quadratic formula, just to get some more practice with it. So, with our quadratic formula, I have my a, b, and c up above there. So, I'm going to find x equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's see, for b we have positive 8. For a we have a negative 1. And c is a negative 7. Alright, so x is negative 8 plus or minus, and then let's see what's going on underneath that square root. So we're going to have 8 squared minus 4 times negative 1 times negative 7. So we're getting a 36 there, so square root of 36 is 6, all over a negative 2. So we're getting 2 solutions out. Just going to separate these a little bit. So we get x equals negative 8 plus 6 over negative 2, which would be negative 2 over negative 2, which is a positive 1. And then we have the subtraction, so negative 8 minus 6 over negative 2, which is negative 14 over negative 2, which is positive 7. So we get these coordinates 1, 0, 7, 0. And factoring might have been faster there, but quadratic formula is a little new for us, so I might just grab it now and then so you get to see some more examples with it. Alright, so we have the general shape of the parabola. We have a vertex at 4, 9. So let's see, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a y-intercept at 0, negative 7. 6, 7. And we have x-intercepts at positive 1 and positive 7. And then if we wanted to use symmetry, we could get another coordinate there, which would be about there. So from there, ooh, I missed it. Sorry, these are really difficult to draw on the screen. And as best as we can to grab those points. Alright, so there's our parabola with our vertex, x-intercepts, and y-intercept.